For section 2.3, we're looking at functions. You've heard of functions before and you've dealt with them before, but just a reminder, in a function, each value in the domain, or your input, can only go to one value in the range. So basically, you cannot have the same x value going to different y values. So for the first problem here, we've got 3 points. There is no repeated x in this going to different y values, so this is a function. For the second problem, I have the same x value mapping to 2 different y values. That's not allowed, so this is not a function. So the definition talks about domain and range. What the heck are they? Domain, and there's lots of definitions for domain, but the easiest way to describe it is the domain is just the set of all x's. Whereas the range is the set of all y's. Now, graphically, we can determine if something's a function very easily by using the vertical line test. If a vertical line would hit the graph more than once, then it is not a function. So on 2A, any vertical line that I drew through here would only hit that graph once. So yes, it is a function. Now it also wants the domain and range. We're going to do these in interval notation. The domain on this one, well, graphically, I just think how far left and how far right do I go? This is a parabola. Parabolas are forever widening out. It widens out slowly, but it will always keep widening out. It never stops doing that. So the domain from far left to far right is negative infinity to infinity. The range, the set of all y's, graphically, that's how far down does it go and how far up does it go. So this parabola goes down forever, so negative infinity, but it only goes up to the number 4. So I would do 4 and I would bracket that because it is hitting at 4. For letter B, this is technically an ellipse. If I pass a vertical line through it, it hits it more than once, so this is not a function. It still is a mathematical object, it's just not a function. And we can still do its domain and range. The domain, again, is how far left it goes, which it goes from -4 to how far right it goes, 4. The range is how far down it goes, which is at -3, to how far up it reaches, which is 3. For letter C, this is technically a graph of a cubic, which we'll get more into a little later on. First thing is it a function? Any vertical line would only hit it once, so yes, it's a function. Now, as far as its domain and range, you got to be careful here. These arrows indicate that it's going to go forever left and forever right. It's going to keep widening. So the domain is negative infinity to infinity. And now here's where students will mess this up. They'll think that the range is only from -3 to 3 because they see a bottom and a top. But you have to look at the entire function. This graph is shooting down forever. This graph is shooting up forever. So its range is also negative infinity to infinity. Now for the next 2 problems, we have the equations instead. Now, both of these are functions. So as far as determine if it's a function, they are. We're going to learn more of when we just see these square root functions, rational functions, that we just know that they're functions. But just kind of a general rule is if y equals one thing, it's a function, which is happening in both of these problems. Here's what I mean as a counter to that. If I had y equals plus or minus square root of 4x plus 1, then it would not be a function because y equals two different things. But both of these are functions. But as far as the domain and range, now things are going to get trickier. For letter D, well, the domain, I can have basically two things that hurt domain. I don't want to have division by 0. That's not good. And I don't want the square root of a negative if I'm dealing with real numbers, because I know that would give me the I stuff. So on letter D, this is to help me figure out the domain. I know that I want the stuff that's inside the square root to be positive or 0, greater than or equal to 0. And if I get x by itself here, I get that x is greater than or equal to negative 1/4. That is my domain. I'm just going to put it in interval notation. So my domain is everything from negative 1/4 on up. Now, what about the range? This is where you got to kind of think outside the box. The range is what the y could be. Square roots have to be 0 or bigger. They have to equal something 0 or bigger if we're only allowed to have the real numbers. So the range here is everything 0 and up. Basically, if I were to plug in negative 1/4 into this, that would give me the square root of 0, which is 0. And if I plugged in anything bigger than negative 1/4, it would give me a positive number. So 0 to infinity. For letter E, this is dealing with the other issue we can have with a function, that we don't want to have division by 0. So I asked myself what number would cause division by 0, and that would be if x was 2. So basically, remember, domain is your x's. My domain is that x cannot be the number 2. So in interval notation, that's every number except 2. So the way I'm going to write that is negative infinity to 2 with a parentheses on it, because I'm not including 2, in union with 2 to infinity. So that is the interval notation way of saying, give me everything except the number 2. Now for the range, again, range can be a little tricky. You have to ask yourself, what could this fraction not equal? Well, I know I can't have 5 divided by 0. That wouldn't work. But 5 can be divided by any other number, and I'd get a result. The only result that's not possible is that I cannot take 5 and divide it by something and get 0. That cannot happen. The only way to get 0 from a fraction is if the numerator was 0. But the numerator is not 0. The numerator is 5. So the only number that this fraction cannot be is 0. So as far as the range, y can't be 0. So my range is going to be negative infinity to 0 in union with 0 to infinity. The next concept we're going to look at is how we evaluate a function. So we've got two functions, f and g. And now we have some functional values we want to figure out. So f of 2. Be careful. this notation here looks an awful lot like f times 2. It's a poor notation, but it's what we're stuck with. It doesn't mean multiply f times 2. It means replace the variable with the number 2. So this would be negative 2 squared plus 5 times 2 minus 3. Watch your order of operations. I have to square the 2, which would be 4. There's still a negative out in front. Plus 10 minus 3, and I end up with 3. For letter B, this is showing that it does not have to be a number. It can be a variable itself. So this means take negative r and plug it in wherever I see an x. This would be negative r squared plus 5 times negative r minus 3. Again, PEMDAS says to square first, so negative r squared would be positive r squared, but there's still a negative out in front. Minus 5r minus 3. Now you might be tempted to try to solve, but this is not solving. It's just saying plug it in. So that is my answer. For letter C, I'm using the g function. So it matters what function. So g of negative 3 means plug negative 3 into the g function. So this would be 2 times negative 3 plus 3. That'd be negative 6 plus 3, so negative 3. For letter D, we're seeing that this is not a number or a variable, it's actually a combination, the full factor here. So, still the same thing. Whatever is in those parentheses gets plugged in for the variable. So this is going to be negative a plus 1 squared plus 5 a plus 1 minus 3. Okay, so I got to square the a plus 1 first, and you can do that off to the side, FOIL it out. If you do that, you're going to get a squared plus a, so that's going to be plus 2a plus 1. But there's a negative out in front of all of that, so I'd end up with negative a squared minus 2a minus 1. I've got to distribute the 5 through this a plus 1. I still have minus 3 on the end. Combining like terms, I end up with negative a squared plus 3a plus 1. So again, whatever is in the parentheses gets plugged in for the variable. Now, number 4, we're doing the exact same thing, except we have the graph instead of equations. So this is the graph of the function f. This is actually a lot easier. These numbers, f of negative 2, f of 0, 1, 4, those are the inputs, or you can consider them the x values. All this is asking me is, what is the corresponding y value? What would be the y value that goes with this? So basically, it's just a matter of looking at the graph. So f of negative 2, when x is negative 2, there I am on the graph, the y value appears to be 5. So it's just the coordinates of the point. When x is 0, y is also 0. When x is 1, here I am on the graph, that appears to be going with the number 2 for y. And when x is 4, that appears to be going with 4 for the y value. So graph versus equation, the graph's way easier on that. The last concept we're going to talk about is increasing, decreasing constant. So Increasing means from left to right, I'm going uphill. Decreasing means from left to right, I'm going downhill. Constant, flat, horizontal. So these are intervals, and be careful, students mess this up a lot. I want the X intervals. So on 5, the first one, I imagine somebody skiing or walking along this graph from left to right. So this would be going up forever. This person was walking downhill. So this would be decreasing. From, well, and again, it's the X values. This was happening forever. So negative infinity. Until this person reached the bottom of the hill. So until this person reached right down here, which was when X was -2. Again, give me the X values on this. Well, from that moment, when X was -2, this person started walking uphill, and they did that from X is -2 to X is 0. Again, don't tell me the Y coordinates, tell me the X's. So this person's path, was increasing from -2 for X to 0 for X. And then from there, they were walking on a horizontal line forever, so that's going to be constant. They were constant from 0 all the way forever. So they were constant from 0 to infinity. Oops. Looks like they just threw something up. Get that out of there. Okay. For the next one, again, imagine the person walking on this. They would be walking downhill until they reach this bottom valley here. So this person was decreasing. Oops, that to work again. There we go. This person was decreasing from, against the X values, from forever left, negative infinity, until they reached -1. And again, you're telling me the X number. This person then would be walking uphill from there to there. That's an increase from -1 to 0 for the X values. But then they start walking downhill again. Cancel, didn't want to copy them. They're walking downhill again. Apparently it's not. They're walking downhill again. That means another interval of decreasing. So I'm going to say in union with decreasing from X is 0 to X is 1. And finally, they are increasing, walking back uphill. So another interval of increasing from 1 for X forever to the right. Notice on this one, there is no interval of constant. There's no flat part. They're always walking downhill or uphill on that one.